Following the precise 110 blueprints, we're cutting the massive road wheels, the heart of the Tiger's scale mobility.
Maintaining the 110 ratio, we're installing the custom wooden torsion bar system to ensure scale-accurate bounce. Even at 110, the hull is enormous. We're laminating the oak panels to maintain the massive scale thickness.
The rhomboid shape must be perfectly 110 scale before we attach the chain-driven tracks.
To keep the model consistent, I'm routing the turret interior to save weight while preserving the 110 box structure.
I'm using the lathe to turn the commander's cupola, ensuring it matches the exact 110 diameter from the plans.
We're stacking layers of plywood to simulate the armor, all measured precisely to the 110 thickness specification.
Applying the final smooth epoxy coat to the pike nose, precisely cut to the 1:10 sloped angle.
The miniature wooden hydraulic cylinder is scaled 110 to the original elevation mechanism size.
Fitting the motor and ensuring the gearbox sits precisely within the 110 scale engine bay dimensions.
Each tiny hinge joint for the road wheel arm is measured to the exact 110 suspension length.
This gear train will pick up the dummy shell, raise it, and slide it into the breech mock-up, all operating within the 110 turret space. We're manually switching the wooden levers to demonstrate the high torque low gear at the 110 drive ratio.
We're tidily wiring the receiver beneath the engine deck, all designed to fit the 110 scale components.
The wooden pin and slot mechanism is engaged, locking the turret firmly for 110 scale precision aiming. Turning the wooden bolt to manually tighten the idler wheel to achieve the perfect 110 scale track slack.
Pulling the wooden steering lever to show how power is differentially applied at the 110 scale.
Testing a panel of 5 laminated ply sheets, this thickness represents a specific 110 scale armor value.
We're using a low-power impact driver to test the 110 scale angle of deflection against a flat block.
Both test sections are built to the same 110 dimensions before the comparison test begins. The wooden slats are measured to provide the scale-accurate distance for the standoff armor cage.
We apply the specialized coating to a 110 scale armor panel before the controlled, low-flame exposure. Every seam is sealed to ensure the 110 model's hull is fully watertight for its float test.
Blending 3 stain colors onto the hull, ensuring the pattern breaks up the 110 scale shape effectively.
Ours on the belt sander achieved the smooth, perfectly spherical 110 scale shape of the glacis plate.
We're loading the tank until failure, monitoring the stress on the chassis built to the 110 specs.
Cutting the internal slide tracks so the wooden breech block opens and closes smoothly at the 110 size.
The cycling mechanism is designed to fit the 110 turret and demonstrate a realistic rate of fire. Deploying the wooden flamethrower nozzle from its hidden 110 scale compartment.
Connecting all 3 barrels, each cut to the proper 110 length, to a single rotation ring.
Milling the tiny cooling jacket perforations onto the wooden machine gun barrel at the 110 scale.
The large wooden bearing ring is installed to allow the massive 110 turret to spin smoothly with one finger.
Precision cutting 20 miniature 110 shells and sliding them into the segmented storage rack. Quickly locking the heavy wooden anti-aircraft gun onto its dedicated pivot point at the 110 scale.
From raw planks to the final 110 scale Titan, watch the entire precise transformation unfold in under 2 minutes.
Unlocking the quick release pins to separate the engine module from the main 110 chassis for easy access. Only 6 main wooden pieces are needed for the 110 hull assembly, making this the perfect starter project.
Watching the CNC router precisely cut the hundreds of identical 110 wooden track links for consistency.
Using only a handsaw and chisels to shape the complicated 110 scale gun mantle curves.
Despite the mixed materials, we're carefully shaping the hull to maintain the consistent 110 scale.
Adding hundreds of tiny wooden dowels to simulate rivets, all placed at the scale-accurate distance.
Proving that you can build a detailed, proportional 110 tank using only salvaged pallet wood.
Driving the 110 tank into the sand to see if the engine can handle the high-friction environment without overheating.
Testing the 110 track's traction by driving up a slippery, snow-covered incline with the proportional weight.
Positioning the naturally stained 110 model among the trees to see how well the wood tones blend in.
The trench gap is set to a proportional 110 scale width, and let's see if the chassis clears it. The tracks are churning, pushing the 110 model through the mud to test the durability of the track pins.
Executing a tight pivot turn in the narrow 110 scale wooden street to avoid the roadblock.
Flipping the switch to light up the tiny 110 scale custom-mounted wooden headlights.
We're slowly increasing the ramp angle, measuring the gradient right before the 110 tracks begin to slip. Connecting the tow cable and engaging the powerful motor to pull a proportional weight load.
The fan chamber is integrated perfectly beneath the 110 skirt, ready for the mock hover test.
Adding the final decorative wooden cogs and brass-painted fittings while maintaining the 110 hull size.
Testing the spring-loaded shock absorption on the proportionally enormous 110 wooden wheels.
The corkscrew drill is scaled 110 to the tank's chassis, powered up and ready to spin.
Installing the glowing green LED array behind the wooden vents, all within the 110 rear compartment.
The barrel is precisely cut to the 110 blueprint length before applying the high-gloss black paint.
We're driving slowly to test how the uneven weight distribution affects its 110 turning capability.
Extending the 4 wooden outriggers, perfectly sized to the 110 scale for maximum stabilization.
The single-man crew compartment is carved out, focusing on the incredibly tight 110 interior space.
Using miniature wooden dowels to perfectly replicate the 110 steering levers and foot pedals.
The wooden cupola is rotating smoothly, and we're ensuring the 110 vision block size is accurate.
Creating a highly detailed wooden V12 engine block using thin strips of veneer, all fitting the 110 scale.
Demonstrating the smooth movement of the heavy turret hatch, cut to the exact 110 dimensions.
The magnifying lens is inserted into the wooden periscope, designed for the 110 vision port size.
Mounting the wooden radio set and installing the telescoping antenna pole at the proportional 1:10 height.
Removing armor and installing a lightweight motor, but maintaining the fundamental 110 hull size for consistency.
We're filling the 110 hull cavity with dense hardwood blocks to maximize the tank's final weight.
We're breaking the 110 rule for this one exception, gluing the tiny 1/100 track links with tweezers for a detail challenge.
The acoustic sensor is calibrated to the 110 engine sound, testing its motion control.
Adding large, removable wooden pontoons, scaled 110 to the hull, and launching into the water.
Carving the entire hull from one block, constantly checking the dimensions against the 110 plan.
2 perfectly matched 110 models engage, simulating a slow-motion turret traverse and main gun aiming.
We've lowered the whole chassis, modifying the suspension travel while keeping the 110 hull size.
The tank is placed on the pedestal,
and the detailed 110 scale informational sign is installed.
Capturing their amazement as they interact with the massive, yet proportionally accurate 110 scale model.
Quickly removing a damaged 110 armor panel and screwing a perfectly cut replacement piece into place.
My favorite detail is the hidden motor compartment, and it was the trickiest part to fit within the 110 scale.
The giant 110 tank dwarfs the plastic toy, truly showing the scale of our homemade model.
Isolating the raw sound of the 110 tracks clicking and grinding as the tank slowly rolls forward.